Alright, this is Emilie Ferreira, test correction 1977, part 2. So for 28A, you have to find the electric potential at point P on the axis. And so you know that, what's it called? Oh, okay. So you know that V equals KQ over R. That's the equation for electric potential, and in order to find R, you need to do geometry. So the equation, or the diagram, looks like that, and this is the circle part. This, they give you X, they give you R. You're looking for this. So from A squared plus B squared equals C squared, you know that this is root X squared plus R squared, which becomes your R. So the final equation is KQ over root X squared plus R squared. Okay, that's A. And now for B, the electric potential is the greatest at the center of the ring. So I'll show the diagram again right here, because X, if you plug in X is 0 at that point, and in order, regarding our equation from part A, the smaller X gets, the larger the equation gets. So X needs to be as small as it can be, and in this situation it can be 0, therefore it is 0 at the center of the ring. So the electric potential will be the greatest at the center of the ring. Alright, C. The magnitude and direction of the electric field. So you know that derivative of electric field equals K times a little bit of Q over R squared. And now because you only care about the horizontal force, so in this diagram you have forces going like that, because this force, you can't see that, these forces and this force, they oppose each other, so they cancel each other out. So all you care about is the horizontal force, so you use cosine of the angle, so you do this times cosine angle. And so then you need to find E, so you do the integral of K dq over R squared times, and you know that, again, this picture, this was X, this was R, or this is R, this was X plus R squared. So cosine of that would be X over X, root X squared plus R squared, so times X over root X squared plus R squared. And when you integrate all that out, it becomes KQ over, and then since it's R squared, it would be the square root squared, so it just becomes KQ over X squared plus R squared times X over X squared plus R squared root of that. And that is your magnitude, and it's to the right because any positive charge will get pushed to the right, or to the positive direction. And finally, D. When you make a sketch, you know that all you have to do is, if this is the x-axis, all you have to do is plug in values for x. So in the equation you just found, a smaller value for x is going to slowly increase to the point x on the diagram that it gives you originally. And then as x gets bigger, it slowly decreases, because the bigger x gets, in relation to the equation that we just found, the smaller the equation will get. So at x, so you just plug in values for x. At x equals 0, it'll be 0, and it'll keep getting larger until x, and then it'll decay. The end.